Hello students, welcome you all for the fourth lecturing session. Myself Krishna Prasad is Assistant Professor from the Department of Mechanical Engineering, MIT Mysore. So in the previous class we have discussed with what is meant by the energy, then classification of energy, the classification of energy based on the usage, based on the long term availability, based on the traditional usage and based on the application. The later we are also studied about the India's production and commercial energy usage and its reservoirs. Then we are also studied about what is the energy alternative and advantage and disadvantages of non-conventional energy sources. In the energy alternatives, we are studying with what are the different types of solar energy utilization. So solar energy utilization can be done in two ways. The one it is called direct utilization, other one is called indirect utilization. In the direct utilization, we are studying with what is meant by the solar photovoltaic cell and the solar liquid flat plate collector. Then we are also studying means what is meant by the hydropower. So in the hydropower, we are classified into two types. The one is called small hydropower, other one is called micro hydropower. So this hydropower it is also works on the basic principle of water turbine. Then we are also studying with what is meant by the wind turbine and what is meant by the power obtained in the wind turbine. Then we are also studying with what is meant by the tidal energy, wave energy, ocean thermal energy conversion. Next, in today's class we are studying with what is meant by the tar sand and oil shale. Okay, first of all, what is meant by the tar sand? That is very much important. The tar sand it is also known as the oil sand, and this oil sand or tar sand is a mixture of sand, clay, water and a thick molasses like substance called bitumen. And then what is meant by the bitumen then? The bitumen it is made of hydrocarbon. Okay, the bitumen is made of hydrocarbon. The same molecule in the liquid oil is used to produce the petroleum products or gasoline. Okay, so and this line diagram shows the process involved in the conversion of tar sand into the synthetic crude oil. Okay, so what is meant by the tar sand? How the tar sand can be converted into the synthetic crude oil can be learned with this diagram. Okay, so already told what is meant by the tar sand. Tar sand it is nothing but it is oil sand and it is a mixture of sand, clay, water and a thick molasses like substance called bitumen. Okay, and this tar sand it is usually obtained from the surface mining process. So whatever the sand obtained from the surface mining process, it is first enters into the conditional drum. So in the conditional drum, water, steam and a caustic soda are added. Then it is mixed together. Then slurry is formed. Okay, so very important one. It's called here the sand obtained in the surface mining process. First it is passes to the conditioning drum. In the conditioning drum, water, steam and a caustic soda are added and mixed together. Hence, slurry is formed. So, whatever the slurry is formed, it is then passes into the separation tank. Okay. So, in the separation tank, the coarse sand it is settles at the bottom. Then, fine minerals of matter, water, and as well as fourth of bitumen it is separates at the top surface. Okay, I repeat, in the separation tank what happens? The coarse sand it will settles at the bottom, then fourth of bitumen, fine mineral matter and the water it is settles at the top of the separation tank. Then this fourth of bitumen is added with naphtha and then it is sent into the centrifugal action. So, due to the centrifugal action, what happens? Here, the fine mineral matter as well as water is going to remove due to the centrifugal action. Okay? So, due to the centrifugal action, fine minerals of matter and the water is removed. Then, this naphtha, it is going to combine with the bitumen. Okay? Then, after the centrifugal action, here naphtha can be recovered and recycled. Okay, the naphtha can be after the centrifugal action can be recovered and also reused. Then a fine bitumen it is then passes into the hydroprocessing or desulfurization process in order to converting into the synthetic crude oil. Then what is meant by the hydroprocessing? The hydroprocessing is the process of removing the impurities like sulfur, nitrogen or a metal by combining with the hydrogen. So that is called hydroprocessing or desulfurization process. Okay, so this is the process for obtaining the synthetic crude oil from the tar sand. Okay, so what happens in case of this process? First, initially the sand obtained in the surface mining process enters into the conditioning drum. Here water, steam and caustic soda are added, and then slurry is formed. The slurry is then passes into the separation tank. In the separation tank, coarse sand is settles at the bottom, then fourth of bitumen, fine mineral matter and the water, it is settles at the top. Then it is passes into the centrifugal action. So due to the centrifugal action, your fine mineral matter and the water is going to remove, and naphtha is added with the bitumen. Okay, then after the centrifugal action, this naphtha is removed as well as recovered. Then the fine bitumen is then passes into the hydroprocessing or desulfurization process in order to obtain the synthetic crude oil. So this is the process for obtaining the synthetic crude oil from the tar sand. Next, very important one, it is called what is mean by the oil shale. Okay, the oil shale is a organic, rich, fine grained sedimentary rock containing kerogen from which the liquid hydrocarbon can be produced. Okay, I repeat, what is the definition of oil shale? The oil shale is a organic, rich, fine grained sedimentary rock containing the kerogen from which the liquid hydrocarbon can be produced. Then what is mean by kerogen? Okay, so kerogen, which is highly insoluble organic solvent which converted into liquid hydrocarbon after the distillation process. Okay, which can be converted into liquid after the distillation process. So then how oil shale can be used? This oil shale, after crushing into the smaller particles similarly like a coal, then it can be directly burned in order to produce the heat energy and in order to obtain the electricity. So this is the one method. In the another method, after the oil shells are crushed, then it is heating at the temperature of 500 degree centigrade in the absence of air. Okay, in the absence of oxygen, then crude oil is going to obtain. So this is the utilization of oil shale. Okay, so I repeat, what is mean by the oil shale? So oil shale is a organic, rich, fine grained sedimentary rock containing kerogen from which the liquid hydrocarbon can be produced. Then what is mean by kerogen? So kerogen, which is highly insoluble organic solvent from which the liquid hydrocarbon can be produced. Then how to use the oil shale? The oil shale can be directly crushing into the smaller particles similarly like a coal, then it can be burned directly to produce the heat energy and in order to produce the electricity. This is the one method. And in the another method, after oil shale is crushed into the smaller particles, then it is retreat. That means this crushed oil shells are heating at the temperature of 500 degrees centigrade in the absence of oxygen, then crude oil is going to obtain by the process called pyrolysis. Okay, so by the process of pyrolysis, crude oil can be obtained. And there is some of the disadvantages in using the oil shale. So what are the main disadvantages? Like the use of oil shale is the environmental degradation because of the surface mining process. Yes, so this is the main disadvantage. So that means if you are using the oil shale, it is nothing extracting the oil shale from the surface mining process. So this leads to the environmental degradation problem. Then the large amount of energy consumed for the production of the crude oil from the oil shale. Okay, so you need to consume the large energy in order to crush the oil shale into the smaller particles. So that means it consumes a large amount of energy. Then the disposal of large amount of energy with the spent oil shale after the crude oil. So once the crude oil is obtained from the oil shale, then large amount of spent oil or spent rock have to be disposed. So this the main disadvantage in case of the oil shale process. I repeat, so in the very first we are learned about the tar sand. The tar sand, it is nothing but oil sand. It is a mixture of sand, clay and water and thick molasses substance like bitumen. Here tar sand first it is passed into the conditioning drum where water, steam and caustic soda are added and slurry is formed. After slurry is formed, it is then passes into the separation tank. In the separation tank, coarse sand is settles at the bottom, and then fine minerals of matter and the water as well as the fourth of bitumen, it is separates at the top. Then naphtha is added. After it is then sending it to the centrifugal action. Hence here fine minerals of matter and water is going to remove. So after that bitumen is then passes into the hydroprocessing or desulfurization process in order to converting it to the synthetic crude oil. Similarly, other process is called oil shell. So oil shell means is a organic rich fine grained sedimentary rock containing kerogen from which liquid hydrocarbon can be produced. Then what is meant by the kerogen? Kerogen soluble organic solvent from which liquid hydrocarbon can be produced. So how to use the oil shell? Oil shell can be directly crushed into smaller particles, then burned directly to produce the heat energy and electricity. And another method, after crushing the oil shell into smaller particle, retreat by heating at 500 degrees centigrade in the absence of air, and due to the pyrolysis process it get converted into the crude oil. So this is regarding to the tar sand and oil shell process. Welcome back students. The next topic, it is called nuclear power. So what is meant by the nuclear power? So nuclear power, it is nothing but the electrical power obtained from the nuclear reactions, that is called it as the nuclear power. And then what is meant by the nuclear energy? So nuclear energy, it is nothing but chemical energy released during the nuclear fusion or fission of an atomic nuclei. It is called as the nuclear energy. Okay, and this nuclear energy can be released from two different reactions. The one, it is called nuclear fusion reaction, and other one, it is called nuclear fission chain reaction, and other one, it is also called nuclear decay. Okay, so that means nuclear energy, it is nothing but chemical energy released during the nuclear fusion or fission of an atomic nuclei. It is called nuclear energy, and this nuclear energy can be released with different nuclear reactions like nuclear fusion reaction, nuclear fission chain reaction, and the nuclear decay. Then what is meant by the nuclear fission chain reaction? So in order to understand what is the nuclear fission chain reaction, we need to understand the working of nuclear breeder reactor. So what is meant by the nuclear breeder reactor? So this is called nuclear breeder reactor. So generally the nuclear fuels are available, and especially for the nuclear power generation we are using, it is called uranium atom. So this uranium atom generally available in three forms, that is called uranium 234, uranium 235 and uranium 238. Okay, so these uranium atoms, it's undergo nuclear fission chain reaction inside the nuclear breeder reactor. Okay, what happens inside the nuclear breeder reactor? It is very much important. So first we need to understand the working of nuclear fission chain reaction. Okay, so what happens in case of the nuclear fission chain reaction? Observe here, in case of the nuclear fission chain reaction, the one neutron atom is bombarded with uranium 235 atom, and it splits into two lighter elements like barium and the krypton along with three neutrons, and releases large amount of energy in the form of heat as well as the light. Okay, so this is actually the reaction of the nuclear fission. So observe here, so one neutron atom combined with uranium 235 92, and it releases two lighter elements like barium and krypton along with three neutron and large amount of energy. And the energy liberated in nuclear fission chain reaction, it is 8.2 into 10 to the power of 7 kilojoules per gram. So that kind of very high amount of energy is going to liberate. Observe here, when small particle called neutron is bombarded with uranium-235 atom, it further splits into two lighter elements like barium and krypton along with 3 neutrons, and these 3 neutrons and a large amount of energy in the form of heat and light, and the energy it is called 8.2 into 10 to the power of 7 kilojoule per gram. And these 3 neutrons, whatever liberated, it should be controlled in the moderator. Otherwise, these neutrons are again interacts with the uranium-235 atom and chain reaction is going to initiate. So in order to control the nuclear fission chain reaction, control rods are used in the moderator. So this is called as the principle of nuclear fission chain reaction. Okay, I repeat, what happens in case of the nuclear fission chain reaction? Here a small particle called neutron bombarded with uranium-235 atom and splits into two lighter elements called barium and krypton, and 3 neutrons along with large amount of energy. This energy liberated, it is 8.2 into 10 to the power of 7 kilojoule per gram. Okay, and these 3 neutrons are again interacts with the uranium-235 atom and leads to the uncontrolled nuclear fission chain reaction. Hence, in order to control the nuclear fission chain reaction, inside the moderator we are using the control rods to control the nuclear fission chain reaction. So this is the principle. Then the construction and working of nuclear reactor, that is very much important. So the nuclear reactor, it is mainly consists of breeder reactor, steam generator, steam turbine, generator, cooling water condenser and the cooling tower. Okay, so initially in the nuclear breeder reactor, nuclear fission chain reaction is initiated and it is controlled and sustained at the steady rate, and then whatever the large amount of energy liberated due to the nuclear fission chain reaction, it is absorbed by the coolant in the nuclear reactor. Okay, it is absorbed by the coolant in the nuclear reactor, and this coolant is passes through the tubes of the heat exchanger, and this coolant transfers its heat to the water in the steam generator. So whenever it transfers its heat to the water in the nuclear steam generator, hence steam is going to liberate it, and this steam is then made to flow over the steam turbine. So in the steam turbine, the heat energy of the steam is converted into mechanical energy in the form of rotation of the shaft, and which in turn drives the electrical generator to produce the electricity. Then again this coolant is cooled with the help of the cooling water condenser, and then again it is sent back to the nuclear reactor. I repeat, here parts of the nuclear reactor are nuclear breeder reactor, steam generator, steam turbine, generator, cooling water condenser and the cooling tower. So in the nuclear breeder reactor, nuclear fission chain reaction is initiated and it is controlled and sustained at the steady rate, and large amount of energy is liberated in the form of heat and light, and this large amount of energy is absorbed by coolant in the nuclear reactor. Hence these coolants are get converted into the whatever the heat energy absorbed by the coolant is transferred into the steam generator, and in the steam generator this heat energy is absorbed by the water, hence it get converted into the steam. Then steam is then made to flow over the blades of the turbine in order to convert the heat energy of the steam into mechanical energy in the form of rotation of the shaft, which in turn drives the electrical generator to produce the electricity. So this is regarding to the nuclear fission chain reaction. Then the last topic in today's session, it is called the nuclear fusion. So apart from the nuclear fission chain reaction, we need to study what is meant by the nuclear fusion reaction also. Okay, so generally nuclear fusion reaction, it occurs in all the stars as well as in the sun. Okay, in today's class first we are learning with the definition of the nuclear fusion and the example of the nuclear fusion, and how the nuclear fusion reaction is going to take place inside the sun, And how is the amount of energy liberated during the nuclear fusion reaction compared to the nuclear fission reaction. Then we are discussing with advantage and disadvantages of the nuclear energy. Okay, so we studied what is meant by the nuclear energy. So nuclear energy, it is nothing but chemical energy released during the nuclear fusion or fission of an atomic nuclei. It is called as the nuclear energy. And this nuclear energy can be liberated in two ways. The one, it is called nuclear fusion, another one it is called nuclear fission. So in the nuclear fission chain reaction we studied, it is nothing but when neutron is bombarded with uranium-235 atom, it further splits into two smaller elements like barium and the krypton, and 3 neutrons along with a large amount of energy in the form of heat and light, and the energy it is around 8.2 into 10 to the power of 7 kilojoule per gram. So this is the amount of energy liberated in case of the nuclear fission reaction. Similarly, what happens in case of the nuclear fusion, that is also very much important. First of all, what is meant by the nuclear fusion? So nuclear fusion is a process in which atomic nuclei are fused together to form the heavier nuclei. So this is called nuclear fusion. Okay, so in case of the nuclear fission, here atoms are splitting apart, but in case of the nuclear fusion, atoms are fused together to produce the heavier nuclei along with the liberation of large amount of energy. So this is called it as the nuclear fusion. Then what is the example of nuclear fusion process? The main example for the nuclear fusion process, it is called as the sun. So the sun is also like similar to all the other stars, it will liberate the heat and the energy by fusing the atoms together. So then what happens inside the sun? So inside the sun, here hydrogen nuclei are fused together to form the helium. Okay, and also this nuclear fusion reaction, takes place at a very high temperature and it releases the enormous amount of energy in the form of heat and light. And also which reaction is going to take place inside the sun, that is very much important. So inside the sun, generally proton-proton chain reaction is going to take place. And inside the sun, the hydrogen nuclei are fused together to form the helium in 4 different steps. Okay, so we need to carefully observe the 4 steps. The first step, it is called, here 2 pairs of proton are fused to form the deuteron along with positron with the emission of the energy. Observe here 2 pairs of proton fused to form deuteron and positron with the emission of energy. So observe here, this is the one proton, another proton fused together to form the deuteron along with positron and emission of energy. So this is the step 1. Next, in the step 2, this each deuteron fuse with additional proton in order to form the helium-3, and it releases the energy in the form of gamma rays. So this is the step 2. Okay, I repeat, what happens in the step 1? Here 2 pairs of proton fused to form deuteron and positron along with the liberation of energy. Then in the second step, then each deuteron fuse with additional proton, then it leads to the helium-3 along with the liberation of energy and the gamma rays. So this is regarding to the step 2. Observe here what happens in the step 3. Here 2 pairs of helium, fuse together in order to form the beryllium. Okay, observe here 2 pairs of helium fuse together to form the beryllium. But this beryllium, it is an unstable one, and this will disintegrate into the helium as well as 4 helium as well as the proton, and the liberation of energy during which it is around 17.59 mega electron volts. So this is the fusion of hydrogen molecules into the helium along with the liberation of energy in the form of 17.59 mega electron volts. This is what happens in case of the sun. Okay, then observe the step 4. So here the 4 protons are fused to produce 1 helium, right? Here 4 protons are fused to produce 1 helium and 2 positron, and releases the energy in the form of 17.59 mega electron volts. But if the splitting of 4 helium atoms, then it produces the energy of 24.7 mega electron volts. So compared to nuclear fusion and the fission reaction, the splitting of the helium atom, it itself releases the large amount of energy instead of fusing the 4 protons. So this will leads to the, so the nuclear fusion, it is always having the lesser power compared to the nuclear fission. So this is regarding to the nuclear fusion reaction. Okay, I repeat, what is mean by the nuclear fusion? The nuclear fusion is a process in which atomic nuclei are fused together to form the heavier nuclei. For example, sun. Inside the sun, usually hydrogen atoms or hydrogen nuclei are fused together to form the helium. And inside the nuclear fusion reaction, it is nothing but proton-proton chain reaction. And in order to conversion of hydrogen nuclei into helium, it happens in the 3 steps. In the first step, 2 pairs of proton fuse to form deuteron along with the positron and along with the liberation of energy. Observe here 2 protons are fused together to form the deuteron, 1 positron, and along with the liberation of energy. Then this deuteron again combined with additional proton, and then helium-3 is formed along with the liberation of energy and the gamma rays. And these 3 heliums, like 2 pairs of 3 helium, are fused together to form the beryllium-6. But it is an unstable one which disintegrates into the 2 protons and 4 helium, and along with the liberation of energy 17.59 mega electron volts. But the splitting of 4 helium atom itself releases the energy of 24.7 mega electron volts. Therefore, whatever the power obtained from the nuclear fission reaction, it is always higher than the nuclear fusion reaction. So this is regarding to the nuclear fusion. Next, advantages of the nuclear energy. The main advantages of the nuclear energy, it is called here, the small quantity of fuel can generate the large amount of energy. Yes, here only 4 proton atoms are used in order to release the 17.59 mega electron volts, and also the splitting of helium atom itself releases the 24.7 mega electron volts. So this kind of very high amount of energy can be liberated with the help of the nuclear energy. Then it is not affected by adverse weathering condition. For example, if you consider solar energy, it can be affected with natural phenomena and local weathering condition, and also the movement of earth orbit around the sun. So solar energy, it will be diluted source. So similarly, in case of the wind energy also, we cannot expect the same amount of phase and amplitude with the wind energy, and similarly in case of the wave energy also. But in case of the nuclear energy, there is no such problem. That means it is not affected by any of the weather condition. Next, the nuclear energy generation, it requires very less floor space compared to the solar energy, wind energy, tidal energy, and ocean thermal energy conversions. Then it is more reliable in operation compared to other non-conventional energy sources. Then the cost of power generation is also very much less compared to the fossil fuels. So the fossil fuels are usually extracted from the fractional distillation process, and then it is converted into crude petroleum oil. But the nuclear energy can be obtained with the nuclear fission or a nuclear fusion chain reaction. It is comparably less cost compared to the fractional distillation process. Then very important one, the nuclear fuel, it is usually used in the transportation system, especially in the nuclear submarines. Then it is also reduces the demand of conventional energy sources like fossil fuels. By using the nuclear fuels like uranium, plutonium, borium and thorium, it will going to reduce the demand of conventional energy sources like especially fossil fuels like coal, liquid fuel like petrol, diesel, kerosene as well as the LPG. So then the main disadvantage, it is called the disposal of nuclear waste is a major problem. And also radioactive element, it is a very hazardous, it cannot be disposed very easily as compared to the other wastage of other conventional energy sources. And the maintenance cost is very high, because in case of the nuclear fission chain reaction, whatever the nuclear fission chain reaction is initiated, it should be controlled and steady rate. Otherwise this nuclear fission chain reaction will be continuous and it will be get effect. So in order to avoid that, so we need to use the moderator and in order to control the nuclear fission chain reaction. So the maintenance cost is very much high in case of the nuclear energy. So this is regarding to the nuclear energy. So the main advantages we are already studied. It is nothing but the small quantity of fuel can generate a large amount of power. So then it is not affected by any of the weathering condition. It requires the less floor space, more reliable in operation, and the cost of production of is also very much less compared to the fossil fuels, and it is mainly used in nuclear submarines, and it is also reduces the demand of conventional sources like fossil fuels. But the main disadvantages, it is called the radioactive waste is hazardous, then disposal of the nuclear waste is it's not very easy, and it is also increases the maintenance cost. The last part of the energy alternative, that is called geothermal energy. Here what is mean by the geo, that is very much important. Geo means earth, thermal means heat energy. That means geothermal energy, it is nothing but heat energy stored deep inside the earth crust, that is called geothermal energy. In general words, we can also say it is the energy which is lies or embedded within the earth crust. Okay. So what is meant by the geothermal energy? Geothermal energy, it is the energy which lies or embedded within the earth crust. Or we can also say that geothermal energy, it is the heat energy stored deep inside the earth crust. Then what are the examples of geothermal energy? That is very much important. The main examples of the geothermal energy called geysers, volcanoes, boiling mud pots and hot springs. So these are all the evidence for the availability of geothermal energy or heat energy deep inside the earth crust. Okay, I repeat, geysers, volcanoes, boiling mud pots and hot springs are the visible evidence of the hot reservoirs are available deep inside the earth crust. And most of the geothermal energy like geysers, boiling mud pots and hot springs are produces a low heat of about 50 to 70 degrees centigrade, and this can be used directly for thermal application. Okay, and also occasionally geothermal heat available at the temperature of 90 degrees centigrade to 450 to 550 degrees centigrade. This is particularly at a place of volcano regions, from which electrical power production is also obtained by running the turbine. Okay, so this is regarding to the usability of geothermal energy. So how geothermal energy can be used? In most of the geothermal energy like geysers, boiling mud pots and the hot springs, it produces a low heat of about 50 to 70 degrees centigrade that can be used directly for thermal application. So that's why it is called low energy density. But occasionally geothermal energy, it is also available at the temperature of 90 degree to 450 to 550 degrees centigrade, especially in the volcano regions, from which electrical production can be possible by running the turbine. Okay. Next, there are two ways of electrical power production from the geothermal energy. It is possible. Very first one, it is called heat energy transferred to a working fluid which operates the power cycle. This is the first method, and this especially or particularly takes place at volcano region. So, in this condition, here cold water is pumped down under pressure into the underground, where it is heated by geothermal reservoir. Once it is heated, the cold water is get converted into the hot water. This hot water is come to the surface under pressure. Once it is reaches the surface, then this heat it is transferred to the secondary working fluid. Once it transfers its heat to the secondary working fluid, then working fluid it is changing its phase from liquid fluid to the vaporized fluid. Then the vaporized working fluid, it is used to run the turbine and generate the electricity. So that is happens in case of the first condition. I repeat, here heat energy transferred to a working fluid which operates the power cycle. It particularly takes place at a region of volcanoes. Here cold water is pumped down under pressure, then it is heated by the hot reservoirs, then it is converted into hot water, then hot water it is rises up and reaches the surface under the pressure. Once it reaches the surface, then it transfers its heat to the secondary working fluid, then this working fluid changes its phase from liquid to the vapor phase. When the vaporized working fluid, it is made to flow over the turbine in order to convert heat energy of the steam into the mechanical energy in the form of rotation of the shaft, which in turn drives the electrical generator to produce the electricity. So this is the first condition. Next, hot geothermal water and dry steam is used to operate the turbine directly. Here in this condition, especially like geysers, hot springs and in the boiling mud pots, in this condition hot water it is pumped from the underground into the surface under the pressure. When this hot water reaches the earth's surface, the pressure drop is going to take place. Due to the pressure drop, water changes from liquid phase to the vapor phase. That means it gets converted into the steam. Once it converted into the steam, it is directly made to flow over the turbine in order to convert heat energy of the steam into the mechanical energy. Then it is itself drives the electrical generator to produce the electricity. So this is happens in case of the second condition. And during the construction of the geothermal power plant, two things we need to consider. First one, it is called pipes are usually 1 meter in diameter and it can be drilled over a distance of up to 3 kilometers. That is possible in case of the geothermal energy. Second one, the water separators are usually used in order to separate the moisture and the solid particle from the steam. So these are the two things are very much important during the construction of geothermal power plant. Okay, so what is the geothermal power plant? How it going to harness the heat energy stored deep inside the earth crust into electricity that we can be seen from the geothermal power plant. Okay, observe here what are the main parts of the geothermal power plant. First one, it is called generator. So generator, it is used to convert mechanical energy into electrical energy. Then turbine, the turbine it is used to convert the heat energy of the steam into mechanical energy in the form of rotation of the shaft. Then steam separator, the steam separators are mainly used to eliminate the moisture and the sand particle present in the steam. Next, very important one, it is called cooling tower. The cooling tower, it is mainly used to convert the steam into the liquid by condensation process. Then second one, it is called steam wells. These steam wells are drilled 3 km below the earth's surface in order to extract the heat energy deep inside the earth crust. So these are the some of the important parts of the geothermal power plant. So at the geothermal power plant, wells are drilled 1 or 2 miles deep inside the earth crust in order to transfer the hot water from the underground into the earth's surface. Once the hot water transferred from the underground into the earth's surface, the pressure drop is going to take place. Due to the pressure drop, the water turns into the steam. Then it is made to flow over the steam separator. In the steam separator, we are going to remove the moisture as well as the solid particles present in the steam. Then the steam is made to flow over the turbine. So in the turbine, the heat energy of the steam is get converted into mechanical energy in the form of rotation of the shaft. Then this turbine is connected to the electrical generator, which drives the electrical generator in order to convert the mechanical energy into electrical energy. So this is the working of geothermal power plant. I repeat, what happens inside the geothermal power plant? Here the wells are drilled 1 or 2 miles below the earth crust in order to pump the hot water from the underground into the surface. When the hot water reaches the earth's surface, then the pressure drop is going to take place. Due to the pressure drop, then hot water changes into the steam. Then it is made to flow over the steam separator, where we are removing the moisture as well as the sand particles from the steam. Then steam it is made to flow over the turbine in order to convert the heat energy of the steam into the mechanical energy. Then the turbine in turn is connected to the electrical generator to produce the electricity. So this is the working of geothermal power plant. Okay. Next, what are the advantages of geothermal power plant? That is very much important. It is reliable source of energy. That means how much amount of heat energy is stored deep inside the earth crust that can be converted into the electrical energy. That means here easy transformation can be possible. That's why it is called reliable source of energy. Next, second one, it is available for 24 hours per day. That means if we consider solar energy, we can extract the solar energy only in the day cycle, and it is not possible in the night cycle. Similarly, if you consider the wind energy, the extraction of the wind energy or harnessing of the wind energy, it is mainly depends upon the wind direction and the wind speed. But there is no such cases happen in case of the geothermal energy. We can extract the geothermal energy completely 24 hours per day. Next, its availability is independent of the weather condition. That means the harnessing of the energy in case of the geothermal, it is not at all depends upon the local weather condition. So whatever the heat energy is stored deep inside the earth crust, that can be easily converted from heat energy into the electrical energy. Next, geothermal requires little land area compared to the solar energy, wind energy, ocean thermal energy. Okay. So next, it is an inherent storage, no extra storage facility is required. So whatever the heat energy we are harnessing from deep inside the earth crust, that can be easily converted into electrical energy with the help of the small components like projection wells, steam separator, turbine as well as the generator. Okay, there is no extra facilities required in case of the geothermal energy. Next, disadvantages. The continuous extraction of heat from the underground water, it leads to the slumping of land. So that is the main disadvantage in case of the geothermal energy. Then also, it is a low grade heat. I already told, geysers, boiling mud ponds and hot springs are the visible reservoirs which containing the heat energy. So it is having the temperature of about 50 to 70 degrees centigrade, and it is a low heat. So this low heat is always generates only the low energy density. So that is the disadvantage. In case of the geothermal energy, we can extract only low grade heat, hence low energy density is only obtained. Next, drilling of wells of about 3 kilometers, which will makes the noise pollution. So that is the another disadvantage of geothermal energy. Then geothermal energy transfer for over a longer distance, it is difficult. I already told here the wells are drilled 1 or 2 miles below the underground water. So we need to extract the heat energy from 1 or 2 miles. That is very much difficult in case of the geothermal energy. Then corrosive and abrasive working fluid reduces the span of the plant. So I already told here, in case of the especially in the volcano region, heat energy transferred to the secondary working fluid which operates the power cycle. That means whatever the heat energy we are extracted from the underground water, then it is transferred to the secondary working fluid in order to convert from liquid phase to the vapor phase. If the working fluid whatever we used, it is corrosive and abrasive, then it will reduces the lifespan of the entire geothermal plant. So that is the disadvantage of geothermal plant.